Hi, Amar. Then we will go over, live questions, and I also promise that we are going to go over one mind-blowing feature in OpenCV. Okay, let's start with the questions first. So there are questions about projects. For example, I received a set of questions, uh, and somebody wanted to discuss whether it is feasible to make a goofy app, and the app, what it would do, it would look at your face and say whether how rich you are. The idea is tricky. I mean, it's interesting in that you could take the photos of billionaires and take photos of, maybe poor people, and try to build a classifier based on photo information whether a person is rich or not. Now there are a few things here. First of all, I do not think the facial features actually enable you to do that. So the information, just looking at a person's face, whether you can tell that the person is a billionaire or is rich or not, I I'm very skeptical whether that thing would work, especially if they are the clothing, and they are groomed well, and everything else is constant. If you take regular pictures of people, yes, by just looking at faces, you may be able to tell, because maybe a person who is rich would be wearing things which are, expensive clothes, would be better groomed, and things like that. But if you keep all the features constant, if you take a poor person and try to make groom them well, right, and make them dress with good clothes, I don't think there will be any information in the photo to tell you whether the person is poor or rich. So I'm very skeptical about this project. But if you were to build something like this, it would be using a classifier. Yes, you can use deep learning based classifier, or you could use deep learning based classifier would be the way to go. Now, I also want to mention that your thought process is not completely, it's not completely out of the world, or out of the uh, there are people who have tried to do this, and very famous people. So Galton, for example, he was a scientist, I think more than 100 years back. He tried to predict whether you can detect criminals using using facial features alone. So can you look at photos of criminals and detect whether a person is a criminal or not? So he collected a lot of photos of criminals and regular people, and he tried to figure out whether it is even possible. And his conclusion was that it is not possible. And recently there was a paper which tried to predict, the person's whether a person is a criminal or not based on their facial features, and they have reported some good results. I don't remember the name of the paper, but I don't trust I don't trust that paper. It is I don't think there is information in the face. But for the final project, I would be very skeptical. What you may even get good results. You may get good results, but those results would be because the features, it is latching onto features which signify a wealth. For example, the photo could be of very high quality. For rich people, they could be, like I said, they could be better groomed, the hair could be better, and things like that, right? So it could be latching on to those things. And based on that, you could say that the person looks wealthy. But I don't think that it would be feasible to detect their actual wealth. But yes, you can build a classifier whether which says that you look wealthy when in this photo. That is perfectly feasible, I think. Still requires a lot of data. It's not an easy classifier to build, because you're looking at very small differences. So something, when you're trying to build a classifier like a dog versus a cat, the differences are large. So if you take 1,000 images, 2,000 images, you can pretty much build a good classifier. But when you're trying to get minute differences, that's the thing about, people ask how many images should there be in the training set? And one of the things is what is the level of detail you're trying to differentiate. So when you're looking at two faces, and one you're going to say one is rich and one is poor, they are kind of very similar. So you're trying to latch on to very minute features, and so it would be you will need much more data, and it's very easy to get into all kinds of problems with these kinds of this kind of data. So if you do that problem, change the problem statement to something like, do you look rich in this photo, right? And then it will latch on to features which maybe expensive clothes or better grooming, etc. And you'll need quite a lot of data. Okay, so the second question is not about a project. It is about object detection. So the question is, what are the steps that can help in speeding up the learning process, like pre-processing the images and building the model, etc. The ML problem that he's interested in is object detection in an image. So a lot of times it is possible to do, so when you're building models many times, so when you build an object detector, it's not like you will be done after doing building it once. So it often helps if you pre-process some of the things. For example, if you're building a hog-based classifier, you may be able to save all the hog features in an image and then use the hog features, and you don't have to calculate it at every run. But for a particular run, if you want to increase the speed, there is not much you can do because that's limited by the size of your data set. You can prune the size of your data set. Sometimes, with traditional computer vision algorithms, the accuracy does not improve with a lot of data. So if you have, say, 1,000, 2,000 images, you can see improvement in accuracy. But if you start using 100,000 images, you may not see much improvement in accuracy. And you can also remove, you can also do training in a batch-wise way. Like you could take 50% of the images and see what's the accuracy, then keep adding more images. And like I said, you could use pre-processing. All the features that you want to calculate, you can pre-process them and save the features. And so when you're doing multiple times, training multiple times, you do not have to calculate the features again, because calculating the features is also expensive. Is there a standard AWS Linux image with OpenCV, maybe 3.2? I do not know of any AWS Linux image for OpenCV, but using the instructions that we have shared, it should be pretty easy to build it. So just use the instructions that we have mentioned. Just go and build the AMI. I think that's the easiest way. The third question is, instead of using regular EC2 instance, does GPU help for OpenCV? It does help a lot, but not every algorithm is helped by GPUs. There are certain algorithms that use the GPU and certain that don't. But OpenCL is extensively used throughout OpenCV, and it figures out, yes, there is a GPU, and it uses OpenCL automatically. You can also look at the Transparent API. Just Google search Transparent API OpenCV. And if you use the Transparent API, it will try to use all the GPUs, all the cores, whatever is available. It will try to use all of those things to speed up the process. So search for Transparent API. Okay. Now, Leo had a question about his project. It's a long email, so I'm not going to go into it. But here's the gist of the question. So he wants to build a face counter. So how many people have crossed a particular line in a video? And that's a perfectly feasible problem to do. you could either do a people counter, or you could do a face counter. So if you do a people counter and you have a line, and you see whether a person has crossed that line or not, and you can also look at which direction people are moving. The multi-tracker that we explained um, in the previous lecture, that would be very helpful. You could use the multi-tracker to track the people and know that it is the same person who is crossing the line. So yes, it is a perfectly fine project for either the face detector based or a person detector based. Both of them would work just fine, and it is perfectly feasible to do it in 40 hours. So that's a good project idea. Now, last week, George had mentioned that we had talked about OpenPose, and one of the questions that George had asked is, can we use OpenPose for detecting the limbs of puppets? So I read through the paper. It's a very interesting paper, very impressive results. I you know It's slightly more tricky. It's using convolutional neural networks to identify the pose of the person. So I think it's not going to work on puppets out of the box. What you could do is, if you make your puppet look like a human, then it's going to work. And the reason is very simple. It has been trained on a lot of of photos and videos of humans, right? And it uses the entire image for doing so. Even for tracking, say, the hand, it uses the entire image. The feature is the entire image, and for each part of the say the hand, it's a pose detector, so it tracks the hand, the head, the limbs, the legs, etc. So for each of them, it tries to determine the orientation as well as the position of some of these joints, and in position as well as the orientation. So they use a convolutional neural network to determine both these parameters together. And finally, because it tracks multiple people at the same time in an image, so they have this collection of objects, a collection of hands, limbs, etc. They have a mechanism to actually figure out which limb or which hand belongs to which person, and they do. It's a very nice paper. They're using some matching algorithms to figure out which part belongs to which, and because they are using orientation in addition to finding the body parts. So not only are they finding this limb, like they could say that, okay, this is the top of the hand, and this is the bottom of the elbow, but there could be another person who could be like that, and to disambiguate which one is which, they use the orientation information. So they also calculate that they try to find a vector which goes from this to this. So if there is a line connecting this elbow to that point, then they have additional information that these 2 points are connected. Even though something else might be like that, like a different hand could be there, but this point is not being connected to this point because the orientation information is missing. So the reason it won't work for puppets is because it has been trained on humans. I don't remember the exact number of images, but it's like in the order of 100,000 images. So it's a lot of images where all these points were manually marked. So MS Coco has this data set. All these joint points have been manually marked. Now you would think that, oh, it's just looking for joints, but it's actually not looking for joints or body parts. It's in context. So what happens is that even though it is looking for a hand, it could be using the information on the face implicitly inside the convolutional neural network. The information about the face also tells you that the hand is here, even though the hand is very far away from the face. Because there is a face, there is some probability that the hand would be, this is a hand of the same person or things like that. So you have to make your puppet look like the human if you have any chance of making it work. And if you want to train it from scratch, that's a very hard problem because training that kind of a neural network from scratch requires a lot of data. And I don't think you will have that much data for the Puppet dataset. You could also fine tune, but even then, even fine tuning your weights, starting with the human data set, that you still need quite a lot of data. So the easiest way is to actually just make your puppet look like the human. Okay. So those were the questions. George, your question about the project, it's more complicated to discuss here, but let's talk over email about that. I'm not 100% sure I understand the project completely, so let's communicate over email so that it will be easy. Yeah, thanks for bringing that paper out. It was on my list of things to do. I had read it once. I had skimmed through it once, but I finally went through the paper. It's very nicely done. It's amazing. The results are amazing. Okay. Okay, so those were the questions. Unless I missed anything, I think those were the questions that were emailed for today. But before we go on to the live question, let me give you the mind-blowing OpenCV thing that I told you about. Now look at, let me switch this display. Okay, so now do you see my screen? Let me know when you start seeing my screen. Yeah, Amar, I'm going to share the paper, but you can look for the word open pose. Open pose. Okay, so here's the thing that I was talking about. Now, okay, it may not be visible. Okay, can you see it? Can you see a live video and a face detector? So this is a live video, and it's a face detector running on it. What's the big deal about it? Well, the big deal is, any guesses? What's the big deal? Okay, any guesses? Exactly. So it is running in the browser. A lot of OpenCV functions are being ported to JavaScript, and this is running in the browser. So I will share this link when I upload. Um, when I upload this video, I will share the link with this video. So it is running in the browser natively. It's using JavaScript. A lot of functions have been ported. Not everything is there, but still, you can make a app. This is, I don't remember what is the FPS on this, but it's at least running at 5-6 FPS, which is great. I mean, for a face detector. So there are other things you can do also, like this. It shows OpenCV JavaScript tutorial. There are a lot of demos in this page, image processing and stuff like that. And it's perfect for image processing. If you want to build an app that does image processing in the browser, then you pretty much have a lot of things done here, changing color space, smoothing, etc. So yeah, it's pretty decent. I mean, I was impressed by what I saw. So I will share the link with you. and it's I think it is part of OpenCV 3.3. This is the first time I have ever seen this. Um, so I'm very excited about this, and so that was the thing that I wanted to share with this. So back to my video display. It is OpenCV's phase detector. Scott, that's right. It is using, so all the functions that you saw over there, they are OpenCV, part of OpenCV has been ported to JavaScript, and that's what the news is. Okay, so let's look at the questions that I saw here. So Amar is asking whether we can use a palm detector that can validate Indian palm astrology. So I don't know about astrology. I don't think that it works, but you can definitely write a palm detector that detects the palm, and then you can do whatever you want to do with it. But it's relatively easy. I don't even think that you need that many examples. If you get 100 examples of like a palm like that, that may be enough to detect. Not 100, maybe 200, 300 should be enough. So Bala, I don't know what is the question. Do we need to convert to color image to grayscale? I'm not 100% sure what the context is. Hi Pankaj. Okay, so I'll just finish George's question. How about training training it with? So it is again about the Puppet pose estimator. So his question is that how about training it with a custom smaller data set with puppets only? And the thing is that you cannot use a very small data set. It needs to be substantial data set. And the data set itself is not trivial to make. So you have to mark all the points of the puppet. So it's quite a lot of work. So I already mentioned Amar. So it is OpenPose, but I'm also going to link to the paper in when I upload the video. Yes, George. So it's not real time. It's I mean a lot of things are running on my machine, but even then I don't expect it to be real time. But still, I mean it's in a browser, so that's fascinating. You can do something with it. So Leo, I actually have not done my research to figure out what it is using under the hood. Is it anything special or plain old JavaScript? I actually don't know. George, that's good to know. I've never used it. Um, I've never used to compile C++ to JavaScript, and frankly, I don't know what they are using. So it would be good to, uh, after this course is over, I will actually do some research on that. I'm very excited about that. So, Scott, are you talking about the facial landmark detection? Okay. So in facial landmark detection, we are not using deep learning, but yes, we are using. So the training set informs. So there are two things actually. First of all, there is the architecture, the cascade that has been defined, and there are parameters in the cascade. You can think about the whole thing as a black box, and there are these knobs that you need to figure out. Once you fix these knobs to the correct value, you would get the right results. Given a face, you would get the landmarks properly. Now, these knobs are fixed using the training set. Because in the training set, you know what the image is, what the input is, and what the output is, and that is why you're able to fix the weights so that it gives the right results. Does that make sense? So it knows the right weights, the right parameters because of the training set. That's the purpose of the training set. Yes, so in a classification problem, if you're trying to classify between tigers and bears, you're trying to differentiate between the two things. In that case, yes, because you have a training set which has known labels. So if you put in the information, put in an image of a tiger, and the network says bear, it means that that's an error. And so you can go and fix the weights of the network. So you can fix the knobs of this network so that it starts saying that it is a tiger, not a bear. So because we have the training set with labeled example, we are able to do this correction. In deep learning, this algorithm where you use the error to fix the weights, that's called back propagation. Let's go over. So face recognition, let's hold on that question for next time. We are covering face recognition in this module, the next module that's coming. So Ross, I want a multi-object. I want to detect multi-objects in a phone video in real time. Objects could be any object. I want the app to draw rectangles around each object so they can be selected by the user. Okay, so Ross has this question that he wants to build an object detector. Now, the thing is that if you want to detect an object, you need to know what you want to detect. If you don't know what you need to detect, then the space is very large. You just, a lot of things look like objects. So you need to know what you want to detect, and then you can actually build a multi-class object detector where a single detector can be trained to detect multiple objects. That's done, there are deep learning algorithms. On the phone also you can do. Look at something called YOLO2. YOLO2 is a deep learning based multi-class object detector that will allow you to detect multiple classes, people, cats, dogs, whatever you have trained on. But you cannot build something, an object detector where the definition is missing. You have to tell what objects you're interested in. And some objects are easier, like, pedestrian would be easier than, say, a table, which has many different views. So oh, great. Thanks for checking, George. So it is cross-compiled. So it looks like the JavaScript version is compiled from C++, using, mscript 10. No, so segmentation is a different problem. So again, segmentation is a funny problem because unless, segmentation is a funny problem because unless you know what you want to segment, there is no good segmentation. Like in some easy cases, you can say that, yes, suppose there is a person in the foreground and there's a background, you can say, yes, this is what the result of segmentation should be. And if you're looking at general purpose object detection, there's something called region proposals. So there are search for something called region proposals. What it does is in a lot of modern deep learning based object detectors, there is another network that is trained that tries to find objects. Because if you try to find object, like in Hog, we are trying to find the object at almost at every pixel. We jump around, but we are trying to find the object at pretty much every pixel. But if object detection, if the classification problem is expensive, then it's very expensive to actually go and look at every pixel. So people do something called a region proposal network. What it does, it tries to find all different kinds of things that can be objects. It doesn't know which class it belongs to. It just tries to find objects, right? And it's very noisy. It's very noisy because you can get, for an image, you can get 300 region proposals, and it will have some measure of objectness. It will say that, yeah, with this probability, it is an object. But usually the output of this region proposal network, it is fed to a classifier to classify it. Otherwise, it's very noisy. So yes, you can have an object detector without actually having knowing what object in it, is there, but the results would be very noisy. One other thing you can check in OpenCV, it is called SuperPixel. So what SuperPixel does is, it's a kind of segmentation. It Instead of a pixel, it groups regions of similar color and similar texture together. So you can look at that, and you can tune it so that it detects regions of large sizes, and then you can say that this is an object and put a bounding box around it. But without the identity of the object, it's going to be very noisy. Without knowing what objects you want to detect, the output would be very noisy. Yeah, so faster RCNN, part of faster RCNN is it has an RPN. It trains an RPN and a classifier at the same time. So faster RCNN does that. So any other questions? Let's see. So how is the project proposal coming along? What other projects people are thinking about? If you have any questions, I'd be happy to. So region proposal network plus a multi-class classifier can do general object detection. So one other thing, I mean, it's something similar. You can look at something called selective search also. So the keywords that you should look on Google is region proposal network, selective search, and those kinds of things. No restrictions at all. I mean, I would be really happy if it is towards a commercial product. So I have in the license it says that it's for personal non-commercial use, and for if you want to use it for commercial use, you should contact me. And the thing that I'm thinking about is that if it is a single person trying to develop something, there would be no licensing fee. I'd be happy if you have taken the course, go ahead and use the code in your personal projects, even commercial projects, no problem. Uh, the thing that I don't want is, if it is a bigger company, then of course a small licensing fees would be good. But if it is just you, not alone, or a couple of people, a very small company like 2 or 3 people, then I don't intend to charge any licensing fees. But I do want you to write to me so that I can formally provide the license. Um, yeah, so I'll be very happy if somebody uses uh, the code that I have in a commercial product. Yeah, that would be excellent. That would be excellent. Sue, I don't know how to. I'm not sure I'm pronouncing your name correctly, but Sue, it's a very good idea to use face recognition as a password manager. It will work. Even better would be something like, so you recognize the face, but then you do something with the face uh, to tell to have a password. Something like you first recognize the face and then you do lift your eyebrows or smile to unlock, so that people don't use your photo for to beat the system. So, Scott, we are going to teach face recognition in the next section on Monday, and those tools can be used easily to build a face recognition based password manager. But it would be nice. But it would be very easy if you just do that. That would be just a few hours of work. But if you want to get fancy, try to do liveness also on top of it, and it may not be even. It could. You don't even need to do liveness. You could have a facial password where you do a smile or a wink or something to tell that it is a password. So that would be a stretch goal, but it is worth trying for that kind of extra, not a simple face detection which does verification, but in addition to face recognition, you are doing something extra. So it would be very cool. So Mahendra, Pankaj, Bala, Ross, do you guys have project ideas that you're thinking about? Amar? Yeah, so that Amar, that would be like a face swap application. That would be a face swap application. The question is, can you do something better, something better than that? No, you can put them in the same mail. Idea one, idea two. Yeah, Pankaj, you can put them in the same mail. So ears are very problematic. both ear and hair, they are very problematic because ears are not visible most of the time. Um, and secondly, hair is fuzzy. So here it's not clear where the boundary of the hair is. And the techniques that we have taught in this course, they will not be useful in detecting the boundary of the hair. But I can, if you want to do that project, I can point you to the right location. So there is a class of techniques called alpha matting, and we talked about this in the last live session also. So alpha matting allows you to do find an alpha mask for the hair, and then or you could use grab cut also. You could initialize part of the you can initialize grab cut to detect hair as well. So that would be nice if you do that. It's actually a good thing. Ears, I'm not very sure about. They are usually not visible, and a feature they are not. I mean, unless it is from the side, as a feature, it's very difficult to detect ears. I don't know whether there is space carving in OpenCV. I don't think so. I don't think so. So space carving was just for others. Space carving was a paper for determining the 3D volume or 3D based on photos of a shape or an object. You can imagine that you have a statue and you want to create a 3D shape of that statue. So you take pictures of that statue from all the different angles, and then you try to triangulate points. And if I mean, there is no point, there is no correspondence, it's a hole. But if there is a correspondence, then you can find the depth, and so you can carve out the space. Um, so I don't think there is a direct implementation of it, but there are tools in OpenCV which will allow you to do space carving. Yeah, sure. Bala, yeah, you can take up Kaggle competition. It would be even, I mean, it's actually pretty good because that way you can join the competition as well as do the project. So it's actually very good. So just to be sure, people know that everybody has a different project. So whatever project you propose, it's for you only, and you will do that project, right? So Ross, if you want to do multiple object detector, then OpenCV may not be the right one. I will check whether they have implemented OpenCV. So the right way to go for a multi-object detector is to use one of the deep learning based object detectors. And the few things that I can recommend, one of them is called SSD, single shot multi-box. Another one is called YOLO 2. Those are the two that will work on the phone. You can actually port them using TensorFlow. And the ports may be available already. So I think you could go with that because some of those object detectors could be built on hundreds of classes. So you don't have to worry about what object, whether your object is there or not. Most probably the object that you're looking for must be in the data set, so you will be able to get a reasonable object detector just because it has been trained on so many different objects. That your object that you're interested in, it would be there. So my guess is that you could use, um, instead of using OpenCV's API, try to use this single shot multi-box or YOLO 2. And if you are developing for a specific, for a very specific iOS or Android, if it is for iOS, you may be able to use something called CoreML, which is iOS has this new machine learning module that you can use, uh, and it's pretty fast. So uh, you develop your model in this framework called Keras or Cafe, and you can port it to. They provide the tools to port it to the phone. So that's something you can look at as well. So just to summarize, I'm recommending a deep learning based object detector for a multi-class, a general object detector, not OpenCV. And the reason is that OpenCV's Hog-based object detector, etc., they're good for single object detection, but not very good for multi-class object detection. Any other question? So, what is the purpose, Bala? Oh, so if you're building a Python application, then you can definitely use scikit-learn based ML algorithms. OpenCV is actually, I mean, it's okay, but there are several problems with documentation, etc., for OpenCV based ML algorithms. But if you're using Python, then you can definitely go for scikit-learn. I think that's better. But if you're using a C++ application, then just go through the documentation. I mean, there is sometimes it's difficult to find the documentation for OpenCV, but that's a reasonable option. So just to give you an idea, for a lot of material in this course, while dealing with ML algorithms, we had to actually go inside the code, read the code, and figure out what the parameters mean. Even for simple things like SVM, and actually not SVM, SVM is based on libsvm, which is standard. But other simple things like Hog and things like that, the documentation was completely missing. And so we had to figure out by reading the paper what are these parameters. So Bang, it's actually very easy to separate moving. If the camera is not moving, if the camera is static, then you can easily separate moving objects from the background. It is very simple background subtraction. What you can do is you can look at the last, say, 100 frames or something, and then take a median along the time. Take the median, and that would give you an estimate of the background. There are other ways of calculating the background also, which are less expensive, but this thing will also work. You can just take 100 frames and along the temporal direction, along the time direction, take the median of all the pixels. And that will give you an estimate of the background because the median, assuming there is a lot of motion going on, the median will give you when at least 50% of the pixels were of the same color. So that way all the objects, all the moving objects will be removed, and you will get this very nice background. And after that you can just subtract and see where the pixels change by over a threshold. This is not perfect, but this one will at least give you a reasonable bounding box around moving objects. Uh, so that's yeah, and that will Bang. Just to clarify, that kind of thing will be done without can be done without training. Oh, so Scott, you first build a model of the background. using this kind of median filtering, or there are other background. OpenCV also has other methods for estimating the background. Um, I can't remember the exact function that they use. You can use that background estimation technique, or you could actually use very simple median filtering also. Median filtering is more expensive, but median filtering along the temporal domain will give you a very good estimate of the background. And because you do this, you can be doing this in parallel, or you could be doing it occasionally. It usually doesn't matter. You'll get a very good estimate of the background, and you just subtract the background, this image, the background image you have figured out. You just subtract all the channels and then create this delta image. Just do a subtraction and take the absolute value, add the 3 channels, and you will get a blob. Oh, so do you want to do green screen? Green screening, is that what you want? So if the background is simple and solid, then it's actually very easy to remove the background. Yeah. If the objects are moving and the camera is stationary, you have no. It's a relatively easy problem. If the objects are moving and the camera is stationary, you will get an estimate of background using the technique that I just described. And then when you do simple subtraction of pixels, you will be able to get the object out. Everything else, because the background would be relatively simple. It's static in the video, and only the people are moving. But if it is a handheld camera, it becomes tougher, much tougher. But if it is a static video, like a surveillance video, then you can create this estimate of the background and do simple subtraction and get the moving objects out. It would be very good. You just have to remove some noise, small noise. You can filter small noise out, but other than that, it should be pretty simple and should work very well. Yeah, so as long as the objects, so anything that is not moving, if you consider that a background, then it's an easy problem. But if you say that like a car that is not moving is also, it's not part of the background, then that becomes a tougher problem. Then you'll have to do object detection to figure out what is background and what is foreground. But if you, based on motion alone, if you want to do the subtraction, if you want to remove the background, then that's easy. It doesn't matter what color the background is, as long as it is static, doesn't change, and the object color is sufficiently different from the background color, this method will work. Did I answer your question, Bang? Okay. Okay, any other questions? Okay, so if there are no other questions, we can stop. It's we are hitting the 1 hour point. So, but yeah, I mean, people who have not submitted the uh, thanks, Scott. So, people who have not submitted the project proposal, please do so. I mean, it's actually it will push you to do things. Otherwise, this can just be this will keep lingering on. A deadline actually helps a lot. So yeah, it would be nice to see a lot of participation. Thanks, George. And I'll be in touch with email about your project. Thanks, MD. Okay, thanks, guys. Thanks for joining. Bye.